This is section 1.2, and the I can statement is I can solve one and two-step equations. So let's write the word equations right here. And then let's take a look at the warm-up. The warm-up says algebra can be a scary word. You've probably heard of algebra before, but wondered maybe what it is. Well, you can think of algebra as math using variables. And you probably know what variables are. Variables are letters. So here's a question that a lot of people ask, especially people that struggle with math. They wonder all the time. So the question here is, why do we use letters in math? So I'd like you to think about that for just a minute, and we're going to answer that in the next couple of examples right here. But think about, why on earth would we use letters in math? Math usually involves numbers, so why would we use letters in math? So we're going to take a look at a situation that might help us figure out why anybody would want to use letters in math. So in example 1, the Wapiti calendar formula. So at Elk Ridge Middle School, we're the Wapitis, those white-tailed elks. So it says, say you get a job selling Wapiti calendars. You earn $20 every day just for going out and trying to sell calendars, plus $4 for each calendar you sell. How much do you make on a day when you sell? And then we've got a couple of examples of how much you would sell each day. So 2 calendars. Well, let's think about this for just a second. If you go out and try and sell calendars, you're going to be paid $20. Then you're going to get $4. So we're going to add $4 for every calendar. Well, if you sell 2 calendars, that's going to be $8. So I'm going to do it like this. I'm going to do 4 times 2. So there's the $20 for going out, $4 for the 2 calendars that you sold. So that's going to be 20 plus 8. So we end up with $28 that day. On the next one, what if we sold 5 calendars? Well, again, you're going to go out and you're going to get $20 just for trying to sell the calendars. They're $4 a piece, but this time you sold 5. So again, we're going to use that implied multiplication. So this is $20 for going out. Lo and behold, here you've got $20 for the 5 that you sold. So we end up with $40 total if we sell 5 calendars. So 10 calendars, and by now you're probably catching on. We do the $20 plus $4 times however many calendars there are. So this is going to be 20 plus 40. So we end up with $60. So on that day, if we sell 10 calendars, we end up with $60. Well, on this next example, we've got just a blank. So I'm going to put a question mark here. Well, they didn't tell us how many calendars we sold, so let's see how much of this we can write down. Well, we get $20 for going out, and then we get 4 times however many calendars we sell. So we could use a couple of different things. We could do a question mark, because we don't know what that is. We could do something a little bit more clever. We could say, well, we're going to get $20, and then I'm going to do 4 times C, because C is going to represent the number of calendars. We could use almost any symbol we want. In fact, we could even do something like this. We could just put a big blank box right there. But what we normally do is we normally choose a variable. Now, C for calendars is a great choice. We could also do something like this. Lots of people like using the variable X. X is probably the most common variable that people choose. Any one of those would be fine. So I'm going to circle this, and I'm going to put a dotted circle around these, because any one of those would be okay, because we don't know how many calendars we sold, so we don't know how much money we're going to make. We do know that we're going to take 20, and then we're going to add 4 times whatever number they tell us this is in the end. So let's take a look at the next example, or kind of an extension of this previous example. It says, how many calendars do you need to sell if you want to make $100? Well, here this is a little bit different. We know how much money we want to make. So let's write down the fact that we get $20 automatically for going out and selling. And then we're going to write down, I'm going to use 4C, and then we know that we want to make $100. So we want this amount that we make, we want it to be equal to $100, and we've made ourselves an equation. So up here we just had an expression, or we just had a formula for this. Now we know exactly what we want it to equal, and then we can go ahead and we can solve that. I'm going to solve some problems like this in a few minutes, but here's the bottom line. We can use any symbol we want. So we could use a question mark, we could use a C, we could use a box, we could make up some weird smiley face or an emoji or anything that we want, but letters seem to be the most convenient choice. So let's write the word convenient. 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 And then the other thing that we want to keep track of is this. Math with letters can represent many situations all at the same time. So this could have been 50 calendars, it could have been 3 calendars, it could have been 43 calendars, it could have been a whole bunch of different things. But that one expression can represent all of them, and this can save us a lot of time and effort in the long run. So I'm going to put time right here. But it can definitely save us a lot of time and effort in the long run. Well, you might say, well, what's the big deal? Well, the big deal about this is solving equations. So let's write the word equations. Solving equations and using variables. So we're going to write the word variables right here. So solving equations and using variables is the basis for nearly all the math that we're going to do from now on. So we're going to go over some basics and just remind you of a few of these things. So we solve equations using inverse operations. I'm hoping you've heard that word before. Inverse operations undo each other. So whatever math was done, we want to be able to undo that and then solve the equation. So remember, operations are things like these 4 basic operations: add, subtract. I'm going to use the dot for multiply, and I am going to use the bar with the 2 dots on it for the time being. But again, we'll get away from that. Most of the time, we're just going to use a fraction bar. So each one of these is the opposite of one of the other operations. So the inverse of addition is subtraction. That's why you learn how to add and then you learn how to subtract. The inverse of subtraction is addition. The inverse of multiplication is division. And the inverse of division is, of course, multiplication. And we use these ideas that they undo each other in order to solve equations. So let's take a look at this second example here. I've got 4 parts of this, and it says solve each equation using inverse operations. Remember, the point of solving an equation is to get the variable on one side all by itself so we can read the answer off. So on this one, we've got y plus 6 equals negative 10. So we want that y all by itself, so we're going to get rid of that adding 6. So how do we undo adding 6? Well, we're going to subtract 6 from this side and subtract 6 from this side. 6 minus 6, those are called additive inverses. They undo each other. So we end up with a y over here, which is what we want. We want the variable on one side by itself. And then we combine these together. Negative 10 minus 6 is negative 16. Hopefully we're not reaching for a calculator for those, but if we need to, you're totally welcome to. And there's our answer right there, y equals negative 16. Let's take a look at the next one. We want to get the variable by itself. The variable's over here, so we want to undo subtracting 4. So we're going to add 4 to both sides. Remember, you have to do exactly the same to both sides so we keep these balanced. Sometimes that's called the golden rule of algebra. So negative 4 plus 4, that makes 0. So on this side we have a, and on this side we end up with an 11. So a equals 11. And please get used to the fact that we can have the variable on either side. It doesn't make any difference. Just read it from the variable. This is y equals negative 16, and this is a equals 11. Totally fine there, no problem. Let's take a look at this next one. We've got negative 13 times b. Remember, we need to get rid of or undo multiplying by negative 13. Now, we are going to divide, but we're going to divide by negative 13. Some people will think of this and they'll say, oh, I need to do the opposite, so I need to divide by positive 13. If you did that, we'd have a negative divided by a positive, and that would leave us with a negative b. We don't want that. So negative divided by a negative is positive. That's what we want. We end up with a b over here. Again, we're going to divide both sides by that, and 52 divided by negative 13. If you need to throw that in your calculator, go right ahead. It's going to be negative 4. I'm going to circle that. We can see the work, and then we can circle the answer. Everybody can tell what we think the answer is. Last example on this side, it says x divided by negative 4 equals negative 10. Again, we want to undo dividing by negative 4. So again, I'm always going to put the second one in parentheses. So I'm going to multiply this side by negative 4, and I'm going to multiply that side by negative 4. Notice that I put it up here, and there's a reason for that, because this is written as a fraction. That way I can cancel the numerator with the denominator. I'm really cross-canceling here. So I get x on this side. Whoops, and we've got a negative times a negative. That's going to be a positive, so we end up with positive 40. So there we go. We've got those 4 basic problems done. Each one of them took 1 step. They're very quick. I do have a thought question for you here, though. What does it mean for the number to be a solution of the equation? So y is 40 an answer or solution to this equation. Y is 11 a solution to this equation. Y is negative 16 an answer to this equation. Y is negative 4 an answer to this equation. Well, when we say it's a solution or it's the answer to an equation, What we mean is it makes the equation true. So if we were to take this one and plug it back in here, in fact, let's go ahead and do that. I'm going to go ahead and change colors right here. So if I put a 40 over a -4 and then the other side was a -10, we want this to be a true equation. So we've got positive divided by a negative, that's a negative. 40 divided by 4 is 10, and we end up with -10 equals -10. That is true. Okay, so it checks out. So let's look at a couple that are a little bit more complicated, a little more difficult. And you can see I've zoomed in here a little bit. It says solve the equations using inverse operations. Please note the order that the operations were done. Remember, when we're solving an equation, what we want to do is we want to isolate the variable. And what that means is that's just a fancy way of saying get the variable on one side by itself. So what we do is we isolate the variable term first. So we don't immediately start isolating the variable, we isolate the variable term. So sometimes I'll have my students do this. We've got this term right here, this term right here, and then we've got a term on the other side right here. This one has the variable, so I'm going to put a little dotted circle around that. So we're going to keep that alone for right now. That's what we're going to start isolating right away. We're going to do that by getting rid of the 2. So we're going to undo adding 2. So we're going to subtract 2 from both sides. So that makes a 0. Those cancel each other out, and I end up with x over -9 on this side. And then we've got a 0.9 minus 2. So let's just pull the calculator up and just make sure we're in good shape, and there's no problem doing that. Always a good idea, especially on a test, to make sure you're getting it right. So let's do 0.9 minus 2, and we end up with -1.1. So -1.1. Now I'm in a position where I can get the x completely by itself. Now I want to undo dividing by -9. So again, I'm going to put this in parentheses. I'm going to multiply this side by -9, and I'm going to multiply that side by -9. Those are going to cancel. I'm going to get an x on this side. Negative times a negative is a positive, and 1.1 times 9.9, go ahead and check this. We end up with 9.9. So that right there is the answer. So again, we're isolating the variable, but the first thing we do is we isolate the variable term, and then we work on isolating the variable. So we're going to take a look at this next one, and I've got an asterisk by this because I want to show you something. Some people like doing it this way. To keep straight the sides, they put some lines here. Now some people will put one line, some people will put a dotted line. I like putting 2 because if you put an equal sign and then put a line through it, it means they're not equal to each other. So here's what we're going to do. This right here is the variable term. So if you wanted to put your thumb on that and cover it up, I know you can still see this, but if we were to do that, just pretend that you can't see that. We'd want to move this positive 4.9 over to the other side. So in order to do that, we're going to subtract 4.9 here, and we're going to subtract 4.9 here. Okay, 4.9 minus 4.9 is 0, so those undo each other. Now I'm going to put an equal sign right in here, and then we've got this -5x sitting right there. So we are getting closer. We do need to put those together. If we put -3.7 minus 4.9 together, we get -8.6. And then we're going to finish this off by doing this to both sides. So we're going to divide both sides by -5. Okay, notice that I've done the same thing on both sides. I've got these bars right here that kind of keep that equal sign in the middle there. Those are going to cancel. I get an x over here. We're going to keep that equal sign right in that middle, right there. And when we do -8.6 divided by 5, let's double check and see what we get here. So let's see, -8.6 divided by -5. Whoops, hit the wrong button there. Let's do -5. Double check and make sure I've got it right. We get 1.72. Now we'll normally go to the hundredths place, so we can go ahead and circle that and say that we're done right there. Okay, let's take a look at a couple more here, and then we'll be finished for today. Again, this is the variable term. So that means we're going to keep this on this side. We're going to move the -6, so we're going to do that by adding 6. So one thing that you can do if you would like is you can cross this off and then add 6 to the other side. So we're going to have 18 over here. On this side we're left with 7y. And then again we need to get the y by itself, so we need to undo multiplying by 7. So I'm going to divide both sides by 7. Those are going to cancel. Again, the technical name for those are multiplicative inverses. This is like a 7 and then we're timesing it by 1/7 kind of thinking there. So those are going to cancel off. That's going to leave us with a 1y over here. So I've got a y over on this side, and then I've got 18 over 7. Well, 7 doesn't go into 18 evenly, so we stop thinking of this as a division problem and we start thinking of it as a fraction. You can't reduce 18 over 7. So the cool part about this is when you run into one of these, you're done right there. The answer is 18/7. We're finished. Okay, let's take a look at the next one. Here's the variable term right here, and I am going to circle the negative in front of the 4y also, because that's the coefficient on there. It's negative 4 times y. So we're going to get rid of the 10 by subtracting 10. So this is going to be negative 4y. Over on this side we have negative 38 minus 10. Again, same sign, we find the sum. So this is going to be 48, and we keep the same sign. You can double check that on your calculator if you'd like to. We're then going to divide by negative 4. Cancel those off, so we end up with y equals, a negative divided by a negative is a positive, and 48 divided by 4 is 12. So I'm going to circle that, and that's our answer. So some fairly easy 1- and 2-step equations to practice today. Again, we're going to isolate the variable, but the first thing we're going to do is we're going to try and isolate that variable term. If you do need to circle them to kind of keep those straight, you're welcome to do that. That can be helpful in the long run. All right, good luck.